All right, section 2.1 is analyzing loans. So what we're going to be doing is a comparison of single payment loans and regular payment loans to see which is, or why you get a better deal doing one over the other. So collateral is any asset that is held as security against the repayment of a loan. So when you borrow loans, especially larger loans, they take a look at what your assets are. So things like a car, a house, any larger belongings or anything like that. Those are all assets that they can use so that if for whatever reason you don't pay your loan back, then they can use that as collateral and say, okay, so your house is worth $100,000, you owe us 80, so you're gonna sell us your house and here's 20,000 back. That's not really the way it works, but it's close. Amortization table is a table that lists regular payments of a loan that shows how much of each payment goes towards the interest you're paid and the principal you're borrowed. So we did a little bit about that, or a little of that in that first introductory section. A mortgage is a loan usually for the purchase of real estate, with the real estate purchase used as collateral to secure the loan. So it says, Lars borrowed $12,000 from a bank at 5% compounded monthly to buy a new personal watercraft. The bank will use the watercraft as collateral for the loan. So what that means then is he will own it, he'll have to pay the bank, make payments to the bank, and if he should happen to fail making those payments, then the bank would just, the dog bounty hunter will go grab it and take it from him, and that will negate the payment. Lars negotiated regular loan payments of $350 at the end of each month until the loan is paid off. Lars set up an amortization table to follow the progress of his loan. So here's how he set it up. He said, okay, month 1, month 0, he's just starting with $12,000. Month 1, he's paying $350. Interest paid on that loan then is the balance times it's 5% monthly. So he pays $50 on $50 of interest. So then the principal that he pays from that $350 will be $300. $50 will go to the interest, $300 goes right on the principal. And then it's just subtracting to find his balance. So we want to see how much will he owe at the end of the first year. So we have our table here, and I'm going to go over the first few, and then I'm going to just pause and fill in the rest, and then I'll start explanation again. So you can pause at those points and fill in the numbers, but it's always going to be doing the same calculations, just changing the number up from one line to another. Okay, so his second month, his payment is $350. His balance is $48. Interest paid is the balance that he had, so that was from on the other page. His balance was $1139 or $1139,875. So when you calculate for the next month, then for month 3, if you do your $11,398.75 and you multiply it by 0.05 divided by 12, the interest amount then is $46.23. So if I call this here, I'm just going to call these columns A, B, C, and D. To find your C, then your principal, it's going to be the payment minus, your previous balance minus your principal paid. Sorry, that's for D. Your C is going to be your payment minus your interest. So 350 minus 46.23 is 303.77. So you can see he's paying a little bit more on the balance of the loan because he's paid off a little bit of it already, so he's got less to pay interest on. So his balance then is going to be 10,792.48. So this column, your D, is equal to your previous balance minus your principal paid. So that's going to be whatever was previous balance here was 1139,875 minus your principal paid. So I'm going to pause here for a sec. Okay, so I've just finished filling in the chart here. I wrote my line 4 in my line 3, so I had to change that first line for you, but the rest are good. So you take to find your column B here, you take your balance that you had. So for month 3, I take my 11,398.75. I multiply it by 0.05 times 12 to get 47.49. My principal that I pay then is going to be my 350. My payment is 350 minus the interest paid, which was 47.49. So that leaves you with 302.51. So that means the balance on your loan is then just subtracting your previous amount minus your principal paid. So take whatever was in D, so 11,398.75 minus the principal of 302.51 gives you 11,096.24. And you keep doing that all the way down till you get to the end here. So it says at the end of the first year, how much has Lars paid altogether in loan payments? Well, he's paid $350 for 12 months. So he's paid $4,200 off on his loan. How much interest has he paid altogether? So if you total up column B, you get $516.34. How much of the principal has he paid back then? So if I subtract here, he took out $12,000. And at the end of 1 year, he has $8,316.38 left, so he has paid back $3,683.62 of the principal. So it says at the end of the first year, what is the balance of Lars' loan? Well, it's just this number here, which is $8,316.38. Example 1, solve for the term and total interest of a loan with regular payments. So it says, as described on page 80, Lars borrowed $12,000 at 5% compounded monthly. After 1 year of payments, he still has a balance owing. So in which month will Lars have at least half of the loan paid off? So we're trying to find then N. We're trying to find out the number of payments that he is going to have to make to get half of the loan paid off. So we don't know N. Our interest rate is 5%. Present value was $12,000. Payments that he makes is negative 350, or so he makes 350 on there. Future value, we're not worried about future value. Payments per year are 12 and compounds per year are 12. So if you put this into the calculator, and I will do this one with you. Oh, why I've got so much of it showing. There we go. So if I do my apps, want the finance, the TVM solver. Okay, so N we don't know. Interest was 5. Present value, so because we borrowed the money, it's positive 12,000. Payments, so this is coming out of our money or out of his, so 350, negative 350, 12 payments per year, and 12 what am I looking for? 12 compounds per year. So if I go back up to here, excuse me, hit my alpha, enter, you get 37.07. Let's see if I can slide this over. Nope. Okay, that's not doing what I want it to do, so I'll just... Okay, so it was 37.07, so it's about 38 months. So A said, A asked, in which month will Lars have at least half of the loan paid off? So if it's 38 months to pay off the loan, then about halfway is going to be 19 or about 20 months. I'll put this here. So B part then, how long will it take him to pay off the loan? Well, we've calculated that there at 38 months. And actually for your A here, we could, if we change this, and I'll just do it in another color here. So for A, if we had said future value to be 6,000 on your calculator, it'll actually give you that amount. So let me bring this back up. If I turn here and go to future value of 6,000 and then go back up to the number of months there, you see it's 19.25 or between 19 and 20. So either way you could do it. You could calculate it for the whole thing and then just go half of that, or you could do this as, okay, if I'm paying off half of it, so half of 12,000 means I want to see when my future value is 6,000. C part. How much interest will Lars have paid by the time he has paid off the loan? So in order to use this, you have to use another function on your calculator. I just have to pause here for a second because I need to bring up the right one, and then we'll continue with it. Okay, so to calculate how much interest has been paid by the time the loan is paid off, without doing the table like we had on the other example, on your graphing calculators you can easily find it by using the sum interest function on the calculator. So if you go on your graphing calculators, and it's still in the apps, so you do the apps. I want the finance one, but you have a few choices here. So if you go down to right here, whoops, I went too far. Oh, now it's going crazy. This sum interest one, that funny looking E is the epsilon, Greek letter epsilon, which we use to mean the sum of numbers, and INT stands for interest. So you hit that one. So it's the sum interest, and then we use interest from the first month to the last month that he paid, which was 38 months. So this is the first month interest, and then this is the last month he paid interest. And you hit enter. So I go 1,38 bracket, enter, and it shows $975.66. So that's what you do to calculate the amount of interest that you've paid on a loan. Okay. Trina's employer loaned her $10,000 at a fixed rate of 6% compounded annually to pay for tuition and texts. The loan is to be repaid in a single payment on the maturity date, which is at the end of 5 years. So how will Trina need to pay her employer on how much on the maturity date, and what is the accumulated interest on the loan? So we want to find the future value for this. So if you do this, you can do this either yearly. Actually, no, the first part asks for yearly. I was mixing my two up. So for A, if we do this yearly, our N is 5. So there's 5 years, 5 payment periods. Our interest is 6%. Present value, so you're being given $10,000. Payments, you're not making payments along the way. We want to calculate the future value. Our payments per year are once, and our compounds per year are once. So when you put that into your calculator, and that's just using the regular future value or regular TVM solver, and once you get to future value, you hit the alpha button. She's going to have to pay back, whoops, not $13, $13,382.26. So she will owe, at the end of 5 years, $13,382.26. So the second part says, what is the accumulated interest on the loan? So the accumulated interest is going to be the present value, or sorry, the future value minus the principal. So $13,382.26 minus the $10,000 she borrowed, which leaves $3,382.26 in interest. Okay, B part. Graph the total interest paid over 5 years. Describe and explain the shape of the graph. So I'm going to skip this one just because you're not going to have to do any of those calculations. If you want to know how to do this, I can, if you want to know how to do it, I can show you separately, but we're not going to be doing questions like that per se anyway, so we'll just leave it like that. But you would be using your formula for this would be A is equal to P times 1 plus I to the N. So C says, suppose the interest was compounded monthly instead. Graph the total interest paid over 5 years. Compare it with your annual compounding graph from part B. So we're not going to compare the graphs, but we are going to compare the interest paid. So to do this monthly, I'll do it in purple here. So if she's doing it monthly, then that means instead of having 5 pay periods, she'd have 12 over 5 years, so that'll be 60. Her interest is still 6%. She still has a present value of $10,000 that she borrowed. She's not making any payments. We're going to find her future value. Payments per year is 12, and compounds per year is 12. So when you put that into the calculator, you find that your future value is negative 13. I can't read my own writing here. I think it's 488.50. $13,488.50. So then it says graph the total interest paid over the 5 years, if you did it monthly, and if you did it yearly. So if I do my sums for this, if I compare so for year, I'm just going to do it this way, year 1, 2, 3, 4, 5, sum of the interest yearly. So if I do it yearly, then using my sum of the interest button there, just let me pause and bring that up because I have to bring up the whole thing. Okay, so to calculate this, you could do each one separately, do year 1, year 2, year 3, year 4, year 5, or you could use your sum of interest and do the yearly one and then the sum of interest monthly. So what you need to do on your calculator is you have to first do the TVM solver and set it up so you can see the interest. So this is when I'm doing it just monthly. Or sorry, this is when I'm doing the interest yearly, so I have a future value of negative 13,382, so that's what I would owe. So then I go back into my apps, do the finance, and I want that it was the sum interest was the A, so if I go alpha and then A is math, it'll bring that up. So then it comes up like this, so I put in, okay, I want to know my interest from year 1 when I start to the end of year 5. And it tells me that interest for this, so at the end of the 5 years you pay $3,382.26, which is what we calculated there. If I want to find the monthly, then I have to go back into my TVM solver. So my number here, instead of being, because I'm doing it monthly, that means that I've got 12 payments, or 12 compound periods over 5 years, so that's going to be 60. My compounds per year are 12, and my payments per year are 12. And if I go to my future value, then hit the alpha, $13,488.50 basically. So now, excuse me, if I go into my apps, the TVM solver, but I want the sum of the interest, so I'm going from month 1 to month 60. Oh, where did I make a mistake? Oh, double bracket. I see that I pay $3,488.50. So what you find then is when you have to compound it monthly, because there's more periods to do the compounding, you have more interest to pay. Okay. Annette wants a home improvement loan to renovate her kitchen. Her bank will charge her 3.6 compounded quarterly. She already has a 10-year GIC that will mature in 5 years. When her GIC reaches maturity, she wants to use the money to repay the home improvement loan with one payment. She wants the amount of the payment to be no more than $20,000. So, there's 2 ways of doing this. You can do it on your calculator, but it's actually almost sometimes easier to do to solve by hand than it is to do on your calculator. So if I do this using my formula, my future value, A is equal to P times 1 plus I to the power of N. So she wants it to be $20,000. We need to see how much she has to borrow. That's what we're trying to find, is how much she can borrow, the principal. And the interest she is paying is 3.6% quarterly. So you divide it by 4. And then our N is its 5 years that she's got times 4, so it's to the power of 20. So if I calculate this, I have 20,000 is equal to P times 1 plus 0.009 to the power of 20. So that's 1.009. So if I divide by 1.009 to the power of 20, that will cancel. So when you do that on your calculator, you have $16,718.86 equals the principal. So that's how much she would need to borrow so that using her GIC, she won't have to pay more than that $20,000. So B says, how much interest will she pay? So interest is always your future value minus your principal. So we have 20,000 is what her future value was going to be, and her principal was $16,718.86. So she's looking at paying $3,281.14 in interest. Okay, next one. Jose is negotiating with his bank for a mortgage on a house. He has been told that he needs to make a 10% down payment on the purchase price of $225,000. Then the bank will offer a mortgage loan for the balance of 3.75% compounded semi-annually with a term of 20 years and with monthly mortgage payments. So A part asks, how much will each payment be? So this one has a little bit of it's a little bit different because you have your interest is being compounded at 1 payments per, and your mortgage is the interest is being compounded at a different rate. So this one has your mortgage, the loan is 3.74% compounded semi-annually with a term of 20 years, and your payments are monthly. So your interest is being calculated twice a year, but your payments are being calculated 12 times a year. So our N then in this case is it's going to be, because we're trying to figure out our payments, so it's 20 years times monthly payments, so 12. Your interest rate is 3.75. Your present value is that $225,000, but remember you have to have 10% of it up front, so you're really only borrowing 90% of it. We want to find out what our payment is. Our future value, well, we want it to equal 0. So our payments per year, we're making monthly mortgage payments, so there's 12 of those. But our compounds per year, it says the interest was being done semi-annually, so that's twice a year. So when you put all of that into your calculator, we have 12 times 20 is 240 at 3.75. Future value was that 225,000 times 90% of that. Payment is what we're trying to find. Future value is 0. Payments per year are 12, but our compounds per year are 2. So I go back up here to payments, alpha, enter. So payments are $1,197.55. Okay. B part says, how much interest will Jose end up paying by the time he has paid off the loan in the 20 years. So this one, because you don't have your calculation here exactly of what your interest is, this is where using that other, oops, I have to quit here. So if I use my, no, not Alpha Apps, that's why I'm not working. Okay, I want my finance, I want choice A, so it's from month 1 to month 240. Oops, my bracket didn't go in there. Or my comma, I mean comma 240. So that's how many months there are. Enter. So the interest is $84,911.64. So C says, how much will he pay altogether? So he's taking out the initial amount, and if you flip back to the other screen, that 90% of 225,000 was 202,500 plus your interest of $84,911.64. So the total amount of the loan would be for $287,411.64. Okay, next one. We're looking at relating payments and compounding frequency to interest charge. So Bill has been offered the following 2 loan options for borrowing $8,000. Which advice would you give him? So option A says he can borrow at 4.6 interest compounded annually and pay off the loan in payments of $1,805 at the end of each year. So option A then. Our N then is where does it say how long? Or that's what we're trying to find, sorry. Okay, so his interest rate is 4.06%. Present value, he's given $8,000. He's making a payment of $1,805. $1,800.05. I mean, future value, we want it to be 0. Payments per year, it says he's doing this at the end of each year, so once. And compounds per year is 1. So we want to find out what the N is. Okay, so if we go to our TVM solver here, and we're going to come back and do our interest rate was 4.06. Present value was 8,000. They are putting in $1,805. Future value, we want 0. We're doing it once a year, and the interest is once a year. So go back up here to N. Oh, what did I mess up on here? Oh, I missed, sorry. Payment should have been a negative in front of there. Negative 1.8. Oops. 0.05. So if I go back up, alpha, enter, 4.999, so 5 years. So we'll say this is about 5 years. Option B then. We're trying to find N. So he can borrow it at 4.0%, 4.06%, compounded weekly. So our compounds then are 52 times a year, and pay off the loan in payments of $34.62 a week. So that's weekly payments. Future value is 0. $34.62 are our payments, and again, it's that $8,000 that he's borrowing. So if I go down here, I'm going to change this to negative 34.62. This is weekly, so 52, and weekly, so go back up to N. And you have 254.92, so N is equal to 255 weeks. So 255 weeks, then we want to see what that is in years. So 255 divided by 52 weeks in a year is 4.9 years. Okay, so that 4.9 years, if you change that 52 times, whoops, my 4 is 208, so 255 minus 208 will be 47. So this is actually 4 years and 47 weeks. So then what you need to do is you need to say, okay, so how much did they pay then actually for this loan? So for this loan here, if they made yearly payments of $1,800 basically, so once a year they paid $1,800.05, so that means they paid a total of $9,000.25. So interest then will be minus that $8,000, so it'll be $1,000.25. So this option A loan, you're paying it off in 5 years, because remember it's 4.999 whatever, and you're paying $1,000 in interest. For this loan here, you are paying 255 weeks, and you're paying $34.62 a week. So that means when you multiply, you get $8,828.10. So your interest that you pay here is $828.10. So option B means you'll pay it quicker, and you have less interest. So anytime you can pay off a loan quicker and pay less interest, that's always a better thing. Okay, last page here is just little reminders. A lot of commercial loans are compound interest loans, although you can sometimes get simple interest ones. The cost of a loan is interest charged over the term of the loan. A loan can involve regular payments or a single payment at the end of the term. The same formula that are used for investment situations are also used for single payments at the end of a term. So simple interest formula, and then your compound interest formula. And of course, anytime we can use our calculator to help do that for us, that will make it just that much easier. The interest that is charged on a loan will be less under any or all these conditions. The interest rate is decreased, so if you are able to readjust your loan, you can renegotiate it sometimes after certain periods and get a lower interest rate, then you're going to pay less interest. The interest compounding frequency is decreased, so if you can get say a semi-annually interest or loan where the interest is compounded semi-annually but you pay it back monthly, that's going to be better for you. If you make regular payments, it helps increase or decrease your interest. If you can increase the amount of payments you make or the frequency, or anytime you can decrease that term. So an amortization table is a payment schedule for a loan with regular payments. It shows what happens in each period. So it's just when you actually do each calculation for each payment period. With each payment period, the interest decreases while the principal paid is increasing. So this is happening because the payment decreases the balance of the loan, so then there's less to charge interest on, and then more money to go towards your principal amount. And technology is a good way to investigate those what-if situations. And that's all.